Hello, everyone, and welcome to the top of Mount Pilatus here at Kulm. We're joining here from the central part of Switzerland for a project show from the IGLUNA field campaign. IGLUNA is an international platform for students to test and develop space technology, which is meant for the moon. Today, I have Team Rebels with us, who are going to present a sintering rover, which is meant to build platforms for landing rockets, building streets, and also building the foundations of buildings. Here, we at Space Innovation give the framework from a system engineering perspective to make projects like this happen. And we're very honored to have the team here today. So now I'm pleased to hand over to Michi, the project manager of the Rebels team.
Thank you, Manuel. Hello, everybody. I'm very happy that you are all here. And I would say we just start with the video.
Man muss sich engagieren, man muss Dinge machen, die Spaß machen. Ich sage mal Studenten immer, wenn ihr einen tollen Beruf haben wollt und viel Geld verdienen wollt, dann müsst ihr Dinge tun, die ihr wirklich gerne macht. Und das lernt man am besten nicht nur in meinen Vorlesungen, natürlich auch in meinen Vorlesungen, aber man muss es auch praktisch machen. Und deswegen muss man in so eine Studentenvereinigung gehen, um Raketen zu bauen, um mit Fahrstuhl im Weltraum zu fahren oder zum Beispiel kleine Ballons in den Weltraum zu fliegen, denn da lernt man wirklich eigentlich, wie man es praktisch macht.
In total, the WAR is composed of 5 projects. With the successful launches of Move-2 and Move-2B, WAR satellite technology now has 3 satellites in orbit. Currently, they are developing their next small satellite, Move-3. The exploration of other planets is the main focus of our exploration. With the rover, they are participating in a competition organized by the Swiss Space Center.
Ich sage immer, kommt für die Projekte, bleibt für die Leute. Man kann hier wahnsinnig viel lernen. Es gibt viele Leute, die einfach unwahrscheinlich viel mehr Ahnung in verschiedenen Themen als man selbst hat. Und es ermöglicht einfach nochmal über den Tellerrand rauszuschauen im Studium und da was zu lernen.
VAR rocketry was founded long ago in 1962. At the moment, they are developing the VAR X3, which is set to break the European altitude record for amateur rockets next year. The VAR Space Elevator team is also setting their sights high. With their climber, they are regularly taking part in competitions in Japan and also organize a competition on the Garten campus. VAR Space Labs is our newest team. Their work is centered around experiments in space, most recently growing DNA crystals on board the ISS.
Das ist dann schon cool, wenn die Leute auch merken, was man da eigentlich macht und dann auch Fragen mal kommen ruhig, hey, was treibt ihr denn eigentlich da? Und dann doch die meisten Leute sehr beeindruckt sind, dass Studenten sowas umsetzen können. Da ist man dann schon sehr stolz und sehr happy, dass man bei sowas dabei sein darf.
Hi, my name is Michael, and do you know where I currently am? That's right. Some call it the moon, but I prefer calling it my living room. You may get a bit jealous now, but hey, it's not that easy living and working on the moon, and sometimes it is also a bit exhausting. Let me quickly tell you why. Imagine you want to go grocery shopping. Okay, wait, there is no such thing as a supermarket on the moon. Well then, maybe let's meet up with some friends? Okay, finding a fitting date is not that easy, and also there is no public transport on the moon. Maybe let's keep it more simple. Imagine I'm going for a walk to clear my head. Sounds relaxing, right? Whoa! Well, as I always say, no risk, no fun. And it also gets quite bright up here, so never forget your sunglasses. But the most annoying thing is cosmic irradiation. No amount of sunblock can protect you from that. As you can see, the moon is not a very friendly place to live in. That's why it is very important to build habitats that protect us from the dangers out there. And that's where it really gets interesting. Building accommodations on the moon is definitely one of the harder tasks. withstanding all the environmental factors requires innovative technology in order to keep me safe up here. But hey, we have a solution. Oh, let's have a look at our documentation. Simplicity is the ultimate sophistication. This may sound weird, but I actually agree with Leonardo da Vinci on this one. So why not solve also our problem with simplicity? We could just use everything that's already on the moon. Let's start with the moon dust that's already laying around. You could collect it and pile it up over your building. That sounds like a good idea, right? This is already a very good protection against cosmic irradiation and micrometeoroids. Our research has shown that already multiple options have been tested. You could simply just bring up glue and glue it in place, or you could bring a big laser and melt it in place. We figured we wanted to go another route. When already using local moon dust, why not also use another local resource in order to stick the moon dust together? As scientists have already proven, it is possible to melt the moon dust into a solid block using sunlight. But how does that work, I hear you ask? To get the required power from the sunlight, we actually need to focus it, so we need a lens. This one? No. We need a way bigger lens. This one. This very big lens focuses the sunlight to a very small spot on the ground. This way we get a lot of energy, and a lot of energy gets us a lot of heat. With this heat we can heat up the moon dust to a very high temperature. Actually, the temperature is around 5 times the temperature you would have in the oven when baking a cake. And you are wondering, who is doing all this stuff? Well, for that I came back to Munich and worked together with some fellow students on a really cool research project, and we know you are going to love it. Now, let's unleash the beast. This is Lars. To tell you more about Lars, I would like to hand it over to Maxi, our PC sub-team lead. Maxi?
Thank you, Michi. Let us now take a look at propulsion and chassis. This part of the rover is responsible for driving and the enclosure for the electronics. Additionally, it serves as a platform for the sintering system to be mounted on. There are the wheels, the undercarriage, and the chassis. All these systems have already been developed by many different companies. This helps us because we don't have to start from scratch. However, no one had to adapt their rover to hold a mobile sintering system. So there are still some challenges left for us to solve. Our rover has to be especially parallel to the ground. This allows for a smooth sintering process. To actually measure this, we implemented numerous different sensors and plan to implement even more. Additionally, our rover might have to drive over the surface it just sintered. To minimize the damage it deals to this surface, we are testing a variety of different wheel profiles. The wheels themselves can spin, of course, but they can also steer individually. The motor control, which makes this possible, has been created by our sub-team ESC.
So, as you have seen, we need to drive the rover, and for this it is necessary to control multiple motors. Those motors we use are quite complex to operate, and therefore we need some electronics to do exactly that. For this, we developed our own controlling units, and this controlling unit is called Electronic Speed Controller, short ESC. As we have quite tight space constraints, this board has to be very small, and we also want to control 2 motors at a time, because we want to drive with the wheel, but we also want to steer the wheel to have a quite big variety of different movement options. For this, we need to control the drive motor in the velocity mode and the steering motor at a fixed angle. For this, we need to provide some feedback to our control unit, and we use different sensors to get the current angle or the current velocity. As you can see in this control board, the circuit is distributed in 4 sections. We have here the logic part, which is the brain of our control unit, and we also have this part which senses the current of the motors and also gets feedback from our other sensors mounted on the motors. We also have a power stage which has the task to drive the current to the motors, and we also want to tell this control unit how to move, and therefore we use the communication part, for which we use CAN. As we already said, we have a very tight space, we have to miniaturize everything, and therefore we have very small components, and also we had to use 4 different layers to being able to connect all the different parts of our control unit.
Hello, I'm the lead of the electronic power system, or in short EPS. The electronic power system covers 2 main areas on the rover. We are responsible to power all the other subsystems so that they can do their job. The second key aspect of our responsibilities is that we have to provide a physical communication bus to all the other electrical consumers. This enables them that they can talk to each other. Basically, our system consists out of 3 main parts. Our battery is the main energy storage of the rover. Then we have a monitoring module which observes the operation of the system. The third part are several terminals which are the direct interface between the electronic power system and all the other electrical consumers. Flexibility during the development was one of the key aspects of our system. With a standardized connector, every electrical consumer can plug into one of our terminals to access the communication bus as well as the power supply. A safe operation is the next key aspect of our system. Our battery is a lithium iron phosphate battery, which can be characterized as a very safe technology. It is equipped with a battery management system to guarantee that everything works fine with the battery. Then we have our monitoring module, which observes the whole operation of our rover, and it will report to the rest of the rover. The last, maybe most important aspect of our system is that we focused on gaining as much knowledge as possible during the development. Except the battery, all our PCBs and components are developed by ourselves.
Now you have seen how the rover drives, but let me now explain what the primary use case of the rover is. This is the business end of our rover. It is an instrument which can print shapes onto the ground using only sunlight and sand. It uses a large and very thin lens called a Fresnel lens to capture and focus the energy coming in from the sun. This lens is very lightweight, so it can be easily transported by a rover. The Fresnel lens focuses the incoming sunlight onto a very small spot on the ground. This spot then reaches very high temperatures, so the sand there can partially melt and stick together. So we now know how to heat up the sand and partially melt it, but how do we turn it into something useful? Let the rover show you how it prints. When the rover reaches the correct printing location, it starts looking for the sun using its solar sensors and moving the lens towards the direction of incoming sunlight. When the lens is positioned correctly, it can open the shutter and begin printing. A set of rails mounted on the chassis moves the lens in a programmed direction to print a shape. We can start with a simple line. Then we can move on to stacking those lines together, or printing any desired shape. When the printing is done, the shutter closes and we can examine the print. We are currently working on understanding how to print these shapes efficiently. When we will understand this, we will start stacking those shapes one on top of the other to create a three-dimensional structure. This will be done by applying a new sand layer onto the old one and repeating the printing process. This is all well and good, but how does the rover know what to do, where to drive, or what to print? The engineers at the ground station have to tell it what to do. So this is where operations comes in.
To operate our rover, we developed our own software. We call it the Observatory. We wanted it to be as easy to use as an app on your phone, but provide all the functionality the operators need. Intuitive controls for the user, translated into complex instructions for the rover. Operating such a rover is not a one-man job. Observatory runs on multiple devices at the same time, and you can even take it with you. Different problems require different views on the situation, and because everybody works differently, we provide a lot of customization to the user. Oh, and we are also using cameras. They allow us to see the world through the eyes of the rover and to quickly gauge the current situation. Visualization was a key aspect for us from the start, because only with good visualization the operators know what is actually currently happening on the rover. And with that, all that's left to do is to press send.
Once an operator confirms an action in the control station, or as we like to call it, the observatory, pun intended, our software does some magic and takes care of things from there. Information is transmitted wirelessly to the rover, where a wireless router receives it and sends it to the big brain of the rover, or as we like to call it, the command and log board. Now, the command and log board assumes a similar role as a brain would assume in a person, as in it is connected to every part of the rover and is able to send it instructions as well as receive information from every part. Let's take the example of moving a hand per se. So it starts with a thought. In our instance, this would be the operator sending an instruction. This thought is then acted upon by your brain and the signal is sent to your hand, after which your hand is moved. Your brain is also able to perceive this movement by feeling the actual movement or by touching a surface. So this communication line goes both ways. We are able to, for example, switch on and off the power line which is connected to the motors of the rover. The rover then can confirm that this power line is actually being switched on or off by sending back the voltage on this power line. In a similar fashion, operators in the control room can send instructions to any part of the rover as well as receive different sorts of information about it. All they have to do is click on the part they wish to examine and voila.
Hello again. I hope you enjoyed the video as much as we did. And we also saw already many exciting questions coming in. So please feel free to continue on with posing questions for our team, which is here live today and also joining by Zoom from Munich. Starting with the first question that came in. How are you going to deliver the rover to the moon?
That's a good question. Actually, we would need to deliver it with a rocket to the moon. But honestly, we are not that far for now. We have started. There is still a lot of work to do until we can send it to the moon.
Thank you so much, Michi. The next one is, do you have already a contract with an existing aerospace company for development?
Not right now, but we have an industrial partner where we work closely with, and maybe in the future we can work together to create something beautiful.
Thank you, Markus. So you heard it. The team is still open for collaborators, for sponsors, for partners. The next question is, how will you control the rover remotely? And I believe that was a part of this challenge.
I think Markus again.
Yes, in our case, we use Wi-Fi for everything. For our setup on the moon, you need something else, but yeah, in this case, we have a quite easy setup. In that case, we have our own software on the ground station, which and sends data packets over the internet to the rover, and the rover returns the data and the video feed back to the ground station.
Thank you very much, Markus. The next question, I think we can combine two of these. So can this rover be implemented directly for a lunar mission? Or if not, what would be the steps you would need to take as a team to get there?
Maybe me. Yeah, so currently the rover for a lunar mission, we have simplified the system so that we can actually do it. There is a lot of stuff we had to develop, and we did not account for the additional challenges that come with the moon. We would actually need to sand-proof actually all the joints and all the land, because the sand can be hard to destroyed, and that would be the main points that we still would need to work on before we could send the moon.
Thank you, Michi. The moon is definitely an extreme environment, and there's still a few steps to take. So the next question is, what are the main objectives of this particular system? It looks very exciting, it looks very advanced, but what are you really want to do? Is it just a proof of concept, or do you really want to build something?
So at the moment, as my colleague already mentioned, we're just making a proof of concept here to demonstrate and to try out the technology of solar sintering to see what are the possibilities, what can we actually make of it. But for the foreseeable future, we plan to actually develop this. As of right now, we are only able to center a single layer, so we can only do two-dimensional geometries. However, in order to be able to actually use this on the moon, we would have to be able to print in a third dimension. So we can actually have some use cases which are actually applicable on the moon. I hope
that's very exciting. Thank you so much, Saif. The next question is related to the energy that we have on an extraterrestrial body, which is highly limited. How are you planning to recharge your system on the moon?
Honestly, we haven't worked on that at the moment, but there are multiple options. First option would obviously be to use solar panels to charge the rover. It doesn't need a lot of energy, as the main consumer on our system is actually the lens, and the lens doesn't consume electrical current. On the other hand, we could also use charging stations where we can drive to and charge the rover wirelessly.
Thank you very much, Michi. I believe that's already technology that has been proven for several years now, and I hope you can implement it quite easily for your system as well. The next one is aiming for terrestrial applications for your system. Are there any? And if yes, which would be these?
Actually, yes. I mean, as we have shown, the sintering process also works here on Earth. However, the closer we come to the equator and the better weather we have, the better we can build. And therefore, our system would actually work to sinter infrastructure on regions that are very close to the equator.
Thank you very much. The next question is regarding the IGLUNA project. So you've participated now for a year. What was your learnings out of this, maybe especially focusing on the testing campaign?
So we made a lot of different tests. We were able to show the functionality of the drive system, as well of the payload, so we were able to sit the material. But there's still a lot of tests we have to do after IGLUNA, sadly. So this still has to be done, but we still achieved a lot.
Thank you, Maxi. Glad that you had a good journey so far. The next question is again about the moon. The moon has a very different day and night cycle compared to the Earth. Do you know already how you want to cope with these 14 days of darkness, for example, during mission phase?
Actually, yeah. Actually, I think if Rock is still with us, he would be the best one to answer this question.
Yes, hello, all the way from Munich. Yeah, sad that I cannot be there with you guys, but yeah, let me answer this question. The international community of space agencies is most likely looking at the South Pole for the building of a lunar base. So at the South Pole, we don't really have that 14-day day and night cycle, but we have up to 90% of the time access to solar light. So this would be as a problem that we could solve because the night isn't that long on the South Pole.
Thank you so much for joining in from the workshop in Munich, actually. Rock, thanks for the answer.
Thank you.
The next question, and it's built up on a lot of enthusiasm we get here for this whole project show. Thank you very much for all the congratulations to the team. You did an amazing job, apparently. The next thing is, next iteration, is it going to be bigger? I can just say this one is already quite huge. But are you planning to go larger anytime soon?
I think this is the perfect question for Safe.
Of course it is. So talking about the next iteration, do we want to go bigger? Not for the next iteration, at least. For the short-term future, we would like to make our current system more robust, more reliable. So we would want our software to be more robust. Want our electronics to withstand more abuse, if I might say, be more break and damage proof, and that will also count as it is also to make it mechanically more robust. And before we go into any changes to the system, we would like to create a solid base for development. So this would mean working longer on the current system that we have here and making it more robust and doing longer, more intensive tests to be able to recognize the source of error and be able to also account for them in the software, electronics, or the mechanical side as well.
Thank you so much, Safe, for this very elaborate answer. Next up is someone really intrigued by the design of your wheels. Did you come up by it on your own, or do you look there for some already existing technologies?
So basically the wheels, they definitely already exist. We did not come up with them on our own. Maybe a quick excurse here. The design is meant that we can easily test a few different wheel profiles. So these are not the finally chosen wheel profiles. So don't get hung up on this detail.
Thank you, Maxi. The next thing is looking a little bit towards also our current setting. One of our visitors or viewers is asking, that could be a very great tool for building something in the Sahara. Did you already consider that?
I mean, as I said previously, that would be the best on Earth because we're very close to the equator, so it's very that is most of the time or most of the day. There's lots of sand, so we all the sources, the resources need, and we actually built there.
That's yeah, a very exciting application which could already lie in the near-term future. The next question is again going towards the space mission. Do you already have put some thoughts into fail-safe mechanisms of your system, or can you already think of which are maybe the most crucial parts that need to run very reliably?
Yes, we have put some thought in fail-safe, but it's more the current thing that we have. For example, the shutter. We made the shutter so that when we press the emergency button, it closes by itself without any energy, so that we can make sure if somebody comes too close to the system that they will not get harmed.
Thank you, Michi. So all in all, your system sounds very complex. Do you can you explain to our viewers a little bit on how to come up with a team like this, how you can keep together, and how yeah, our viewers can maybe establish their own group, their own association, following very exciting projects?
I mean, for me as a project leader, it was quite easy with such. We all had the same passion. We had a lot of fun, and we worked very closely together. And I think also the pandemic in some way helped us because many of us didn't have the chance to know other people because we had to stay at home. And so being together online, working on the project, many of us, we all had a lot of fun. And I think that was the main point that brought us to the success.
Thank you, Michi. Connecting to this one, we have maybe a little bit a question that is not directly related to the rover, but maybe to the framework you're in. I heard you're part of a bigger association. Mark, can you tell us if there's any chance for an aerospace engineer at TU München to also join some propulsion-related projects?
Yeah, exactly. So we are part of a bigger association called VAR. It's Wissenschaftliche Arbeitsgemeinschaft für Raketentechnik und Raumfahrt, located at the Technical University of Munich. And yeah, we are welcoming every student who wants to be part of our association. We have multiple projects ranging from rocketry to satellite technologies, but also more exotic projects like space elevator or space labs, which does experiments for the ISS and other low gravity experiments.
That sounds very exciting, Markus. Catching up on that, are you still accepting sponsors?
Yes, we are. Always and very happy.
I thought so. That's not a big surprise, but great to also know this out of this discussion. Let me check if there's still some questions open. Maybe part of IGLUNA, we already heard your experience. What were the biggest challenges you were faced and how did you overcome these?
So from a technical perspective, the rover is rather complex because giant kinematic system starting from the wheels, going through the undercarriage, through the chassis, through the payload, and ending finally in the lens. So the biggest challenge was precisely positioning and moving the lens.
Thank you, Maxi. And I think you're not the only team that went through some challenges. And the next question is, could you consider also working with other teams from the IGLUNA setting together to make a bigger system happen?
Yes, of course, we would always be happy to work with others. For example, there was P6, the inflatable habitat. I mean, in the end, they work on the same problem as we do, but only in a different way. And we already have talked with them, and we were in discussions. And maybe at some point, someday, we would be able to build the habitat together. I think that would be very interesting and very cool.
Thank you very much, Michi. A follow-up question on the VAR, on your association. Are the groups linked? Do they work together on the projects? How is it organized?
All the projects work on their own, but we put a lot of effort in to work closer together. So, for example, we have the satellite team. On the first site, they have nothing in common with us. But if we look closer, they have a lot in common with us. They have developed an awesome software that we are also using, and that simplifies the development of our software a lot. And there are also other corporations within VAR, the same as this one.
That's great to hear. A lot of synergies are going on there, and yeah, if studying in Munich, I would love to be part of this association. So another more technical question regarding or related to your layer. Why would the last layer not melt when it's attaching to a new layer on the top?
I think that's again a question for Rock.
Yes, sure. I am not exactly sure what it is asking, but let me maybe explain a bit on yes, what we are trying to do in applying new layers. This is still a thing that we want to try in further development of the rover. We still haven't tried adding new layers on top of a previously sintered layer, but these processes have already been proven by studies done by the European Space Agency. So that will definitely work, and we will try to implement it in the further development in the next years.
Thank you so much for clarifying, Rock. Heading up maybe in a different direction, but still, can your Fresnel lens be used to cook?
Yeah, yes, it can. We actually tried it. Afterwards, we don't throw away food, and it actually tastes very well. It's definitely possible.
Okay, very exciting as well. Cool stuff. Next question. Did you, like Rock is already joining from the workshop, maybe that's also a question for him. Did you build the entire rover there?
Yes, we built this whole rover in the last year by ourselves. Most of the parts ourselves, but we also used some help from various departments here at the university who have experience with manufacturing complex stuff out of aluminum. So they have big CNC machines that are used for the very complex parts. But yes, we manufactured a lot of the rover ourselves. Also with the use of the machines that we have in the workshop and the machines that are available to us in Makerspace, which is a workshop where students at the university can also work.
That is really impressive. I have the rover here in front of me and it really looks, very professionally built, a serious approach to that one. So congratulations for this very nice work. The next question, again, going towards more technical aspects of your system, or maybe the mission in general. Are you planning to retrieve samples if you go to the moon for a first Pathfinder mission? Are you planning to receive some samples of the sintered regolith? And is there any planning already how this could be done?
Good question. We didn't actually think that far. The goal of the mission of our system is to work autonomously and use in-situ resources. And we didn't actually yet plan to bring stuff back. We still are planning to bringing stuff up. That's the first step.
Super. Thank you for this honest answer. And thanks for these very important questions from our viewers. Maybe to sum up, I think we covered almost all of the questions already, but one last question to maybe close this session. What is the next part you want to improve in your system over the coming months and years?
So actually, the most effort went into automating already some parts of the sintering device. We saw that this greatly improves the performance, but there are still a lot of parts that we can automate, and we think that that's the right direction in order to improve the system a lot.
That's again very, very exciting. Thank you so much for these insights. Thank you for joining in. To all our viewers, it was a great session, very enjoyable. Thanks, Saif. Thanks, Maxi, Markus, Michi, and of course also thanks to Rock back to Munich. And yeah, if you have any more questions, you find the VAR team, the Rebels online. You can also tune in on our website from the IGLUNA project 2021. And yeah, thank you again for your active presentation. And yeah, I think that's all from our side. Have a great day and see you soon.